Okay, so today I want to talk about a stack that I've been using recently for developing ReactJS applications hand in hand with GraphQL. For the past eons, JSON has been the most popular way to interface between your backend and your front end and to publish APIs. But the issues with JSON is that a front-end developer needs to ask a back-end developer for changes, or you may need to constantly be making modifications to your backend. You can try and agree what that interface is going to be using things like Swagger, but Swagger takes a lot of time and effort to maintain, and it can be more trouble than it's worth in having to do that. And the whole interface between backend and front end ends up being fragile, or you have a dependency. You have to publish your front end and back end at the same time to make sure to match up. So it's not a great experience. I've been, like most people, I've been using React and Redux and JSON APIs over the last few years, and it's been fine. It's been, it's had all those issues I talked about. But then I wanted to try and investigate things like TypeScript. Everyone keeps on raving about how amazing TypeScript is, how it kind of helps with autocomplete and type checking, and how it makes your code, it's like back to the good old days where you can compile something and know it works. But I tried TypeScript with Redux, and the two do not go together at all. You end up with a lot more code to try and support TypeScript and the type definitions, and you spend a lot more time thinking about TypeScript than you do by writing your own code. So I don't recommend TypeScript with Redux. The project I moved on to recently, I found the data scientists in there were publishing an API in GraphQL. Now, I'd always assumed that GraphQL was difficult to use. I assumed that writing the back end would be hard work. I mean, after all, the front end says, give me this. So you'd have to create a back end that could do everything, I thought. And from the front end, I thought, okay, I'll give it a try, but then do I use Axios to make HTTP calls? And how do I make it work with Redux? And the short answer is you don't. With GraphQL, it lets the front end tell the back end what it wants. Writing GraphQL servers is much easier than writing JSON servers. You don't have to write a Swagger file because you have this thing called a schema, and a schema defines your data and the ways that you access it and mutate it. And it just makes life easier all round. So I was initially, when you do come across GraphQL, there's always a very kind of steep learning curve. So that I went through this thing of how do I make it work with Redux, and you really do have to think differently and approach it in a very different way. So hopefully, this little demonstration or this little kind of couple of videos I'm going to do will show you. I want to talk you through how to use GraphQL along with React and a few other tools to make a full stack development really easy. And this is now my favorite way of doing things. And anything I start from scratch, I always do with GraphQL using a stack that I'm talking about today. If I have to use JSON, then I go back to that and I use it. I don't use TypeScript, and I'm starting to miss that a little bit. Anyway, hopefully today I'll walk you through how to create to do and how that can kind of explain how the stack works. Now, the first part of this little chat is going to be, I'm going to show you how to, I'll get the fundamentals. I'm going to show you how to set up a full stack, which can have a client and a server. I'm going to assume that you already know Node and Express.js. And I'm just going to go through setting up the basics of a GraphQL server that will be able to give you a list of to-dos. Later on, we'll then go into the front end and we'll start looking at how we use GraphQL in the client along with TypeScript and things like Formic to help you build simple to maintain forms. But without further ado, let's start with actually building an application. So I'm going to create an application called Stack. I've already created the folder, and in that I'm going to set up I've got the package file for my dependencies, and then I'm going to create a couple of subfolders that I'm going to use for the client and server code. So I'm going to put my client code in client, I'm going to put my server code in server, and I'm going to create a package file to hold all this. The other thing I'm going to do is I'm going to actually use Yarn workspaces just so I can type in Yarn install in one place and not have to do it in multiple places. Just makes life a little bit easier, but there's a few things I need to do for that. I need to set private to true at the top level because you're not supposed to publish the top level, don't know why. And workspaces, we'll start off with just by doing the server one, then we'll do the client later. So if I go into my server, I need to do an npm init in there as well. So I need to make sure I'm inside the server, and npm init num. Right. So to do the development that I need to do, I'm going to have to create a couple of dependencies. For the server, we're going to use GraphQL along with the Apollo GraphQL server, and I'm actually going to back it up with a Postgres database and a object relational tool called Nex, which is not the most popular, but definitely my favorite. So looking at dependencies, what do I need to bring in? I need to bring in a few things. Let me just look at my list. So I need to bring in Apollo, Express, GraphQL. I'm going to bring in another thing called import just to help out in a few bits and pieces and some other bits and pieces. Anyway, let's set up our dependencies. And we're going to use NodeMon later on to help us in having the server restart without having to think about it. Now, as I said, I'm going to use a Postgres database for all the work I'm going to do here. The Postgres database, if you can set Postgres up yourself if you want, or you might have access to a server, but today I'm just going to use Docker because I can, using the settings in here, so I can specify the username, password and database that I want to create and a port to expose on. So I'm just going to start up a Docker server, a Docker-based database server, and there we go. So, going back to here, what do we have? I've got a server, I've got some dependencies that are in there now. The next thing I need to do is, as I said, I'm going to be using Nex. Nex, really nice little tool for handling databases. So Nex has the idea of a thing called a Nex file. And the Nex file is where you specify all the configuration information. So, there we go. So in my Nex file, I need to tell it that I'm using Postgres. I need to give it connection details, saying it can bring connection details from the environment if I was going on Heroku or something. Otherwise, I've set up some defaults in here to say how to connect. We also have the idea of migrations. Migrations are different. Next gives you a tool for managing your database schema, so you can migrate up, migrate down. So you say add a table, and then you add another migration, which is add another table, and it manages moving between those different states. So we're going to need the next file to do that, configure that connection. I'm also going to create a file that will instantiate that. So this is the file that I'm going to use from within my code. The reason why you have the two separate is that the next file gets picked up by the command line tool that Nex provides you. Whereas this other little bit of code in here is what I'm going to actually use in my code to connect to Nex. So I'll set up a Nex file, I'll set up Nex in a neat little file there, and I'm going to need to create folders for migrations and seeds. Seeds is I can populate the database with some data to kind of get me started. Now, Next gives you a nice little command line to help you do the things that you need to do with databases. So I'll best if I just show you what it has. So Next, as I said, lets you manage migrations. So you have the migrate commands there for getting that. You can go to the latest one, you can roll back if you made a mistake in your migration. You also have these seed tools which are for helping you populate things. So I want to create, in this instance, a migration. So I'm going to say yarn next migrate like I want to make a to-do table definition. And what that's done is it's created a file over here for me that will help me manage my migrations. And in this case, I'm going to do a to-do table. So going back to my notes, what is a to-do table? The to-do table is a simple table that's just going to store an ID, a title, and indicate whether a to-do is completed or not. So Next has a nice simple way of helping you to define these things. So it's got a special type called UUID, and I want that because I want to store UIDs. I don't want to do sequential. For my ID fields, I have a title that you must provide and a Boolean field to indicate if something is complete or not. And you always, in a migration, say this is what happens when I want to go up to this version, and this is what happens when I want to roll back. So in this case, I say if I need to roll back this change, if I made a mistake in the name of the title, then I could run rollback, and it would run, in this case, it would go and drop the to-do table. I want to create some seed data to kind of get us started. So I want to create some to-dos in my seed data. And I'm going to create just a couple of to-dos in there. And this will show you how the next kind of functions will work, how it kind of gives you some useful stuff. So let me explain what's happening here. I'm using this little utility called UUID to get me a unique ID. Every time you run next seed, it will always look in the seeds folder for modules, and then those modules, it will always look for a seed function. So in here, it's calling the seed function, and it's passing a reference to next. So I created a function that will clear all the records in my to-do table. So no matter how many times you run this, it will always clear the table down and create fresh data. And then I'm telling it to create two to-do items in there. So test action 1, test action 2. So just so we've got something that we can see on the screen. So there we go. So in summary, I have set up my dependencies for Apollo and Express. I've set up a connection file, my next file, to connect to a database server that I started up, and I've defined a table called to do. And now I want to actually get the database set up. So yarn next. So I can do yarn next migrate, and I want to migrate to the latest version. And that ran. So it's run that migration, so I know if I had a database tool, I could show you I have a to-do table, as well as a couple of other tables of metadata in, so it can manage itself, so it knows which migration version it's currently on. And I can do yarn next seed run. And it's run the one seed file, and there's now some data in there. So, database, records, done. Next, I want to write a GraphQL server, which is actually a lot simpler than it sounds. So what I'm going to do is talk a little bit about GraphQL and then delve into actually creating it. So GraphQL, at least within the Apollo client and server, everything kind of centers around something called a schema. A schema defines all the different data types that are in your model, and it also defines the queries that are available to you, so the ways that you can interrogate that data. And it also has the idea of mutations. Mutations are adding things and editing things. And all that gets defined in a schema file. So for the to-do application, I need to set up a schema file to define what I want. So I created a DB folder for my database stuff. I'm going to create a folder called GraphQL, store my GraphQL stuff. And in there, I want to create a schema file. And we're going to be using the GraphQL syntax, so it's schema.graphql. So we're going to have a to-do. So what we're going to do is we're going to define what a to-do is within the schema. It should be relatively simple when you read through this. The idea is that you say you have a type. GraphQL has basic types already, so it knows that you have such a type as an ID, which in this instance, it knows that IDs can be UUIDs. It knows about strings, it knows about booleans, and these bangs on the end tell us that these are required properties of a to-do. You also have queries. So a query is, it defines the different ways that you can get hold of information. So in this case, sometimes I want to get back to-dos, so I have to-dos is the name of the query, and the to-dos query returns back an array of to-do objects, types. I might want to get a single to-do, so if I have a query here called to-do, I can specify that this query has parameters, so in this case ID is a required parameter, and I tell it what the type is, and I specify the return again, so in this case I'm going to return like a single to-do. Mutations let you change things. So within the schema you have the mutation kind of type, which is where you define all the different ways you want to edit information. So in this case I have defined a mutation to add to do. So it's like a function signature. So I was saying there's a mutation function called add to do. It expects a title, and again it's a required field, and it will always return back a to-do object when it's done. Update to do is very similar, except in this case you need to pass it in a to-do ID because it needs to know which one it's changing. You may be changing the title, so you need to provide the title. It could be the original, it could be the new one. And I need to be explicit about whether it's complete or not complete now. Before, when I added a to-do, I assumed that it's not complete when you created it. And again, it returns back a to-do object. And that's it. Schema files can get quite big in big applications, but we don't need to worry about that for now. For now, we have a relatively simple schema. It just says, here's a to-do, and these are the things I can do with it. So how do I turn this into a GraphQL server? It's not that difficult. So what we'll do is we'll work backwards. So if you look at the query here, you can see that it looks a bit like a function signature. You know, it's got a name and it's got parameters and it's got a return type. Well, so what we're going to do is Apollo GraphQL server it kind of works by convention, in the fact that we'll give it the schema file and it will follow a convention to navigate down all the different things that it calls resolvers, which are a resolver just turns a thing in a schema file into a function. It maps the two. So it will follow a naming convention for resolvers to get from the URL of the person and the query information that the person passes to the server to get to a function. It all sounds complicated. It really isn't. So what we'll do is we'll work backwards. We'll create the functions that will handle the queries, and then I'll work back to the point where we've got a server. So in my GraphQL folder, I'm going to put all my queries in one place. So I'll create a new field, and I'm going to call it query, because I want to kind of keep it aligned with query. And within that, I'm going to create a file called Todos. And this Todos function maps, just click that, this to-do function is going to map with to-dos here. So a person's not going to pass any parameters, they're just going to call a function, say give me the to-dos. So in Next, it gives you the ability to pull the records out of a table with a very simple syntax. Or you can, it gives you the ability to either define it using its functions, or you can go all the way to define your requests, the actual SQL for your requests. In this case, we're going to use the fact that it abstracts all that and makes life easy. So I'm including my my Next file that I created earlier on, and that was the thing that created the instance of Next. I'm creating a function which rattles down to a single line. I'm saying here's a function that accepts no parameters, and it's going to return the result of a call to Next, passing the parameter to do. So what it's saying is saying, Next, give me all the records you have in the to-do table. That's what that one for call does. Next works with promises, so it'll return a promise, and GraphQL, understand the Apollo GraphQL client and server, understand promises. So I'm just saying, here's a promise, and at some point I'm going to return back to you the to-do records from that table, and that's it. So let's try another one. We're going to create the query handler for to-do, which is slightly more complex, but really isn't. In this instance, I'm now saying, I've got something wrong here, so let's have a look, see what we got, see what it thinks is wrong. Yeah, I don't need that. Right, so now I'm saying I've got a function called to do. I'm expecting a parameter called ID. I'll talk a little about this later on, but resolvers have all resolvers have the same function signature. And I said a resolver is a thing that takes a request to the GraphQL server and turns it into a function called and returns data. So in this case, the first parameter is something that we're not really interested in. It's actually to do with data that was sent into the function call. You get to that in mutations. The second parameter, the second piece is parameters that get sent. Remember in the to-do function call over here, we had a parameter which was ID. So in here, we're looking for the parameter called ID. And then it's calling next, and next, I'm saying next, get me the records into the to-do table. But this time, I'm actually specifying some criteria. So I'm saying, get all the records in to-do, where ID equals ID, shorthand ES6, and return back the first result you get, because I'm only expecting to get one, because I'm looking for a single unique ID. So it works the same way that does, returns back a promise that eventually resolves to, in this case, a single to-do record. And that's it. I've got back a to-do. So I'm going to do a few bits and pieces to then bring this all together. So these are my two queries. And we'll be adding more over time. But I want to say that the top, basically for index, I'm going to create a single index file that brings in all the different query resolvers. So I'm just going to say import to-do and to-dos, and then export those to be the query object. So you'd have query.todo, query.todos. Just a convention for how I organize my files and how I want to map it in here. So that's good. We're nearly there. So that's the query handlers that we've got for a schema. So we've handled this. Now we need to actually have something that wraps up the whole thing. So in my GraphQL, I'm going to have an index.js, which is going to summarize all my resolvers. And all I'm going to do for now is I'm just going to say that I'm just providing resolvers for query. So here we go. So yeah, query equals required query. Again, it probably looks like overkill when I'm doing this now, but as the code grows, this is a really nice way of organizing your code. So I'm saying query, I'm saying I'm going to create a resolvers object, which is what the Apollo server is going to ask for to help it turn schema stuff into function calls. And I'm just going to export that within an object. So I now have a GraphQL folder that's got an index file that summarizes all the resolvers, and I've got a query folder that's got my query resolvers. The last thing I need to do is actually create a server. So this is the bit where I'm going to build a server. And what we want to do is we want to create a GraphQL server that serves up and looks after GraphQL commands. But later on, I'm going to be introducing ReactJS as well. So I want something that's going to let me do GraphQL, but also serve up some static assets as well. So what Apollo server lets you do is it lets you create a GraphQL server and attach it to an Express.js server, which is exactly what we want. So let's create a new file at the top of our source and create a server. That's not right. Let's try again. Make sure I cut and paste the right stuff this time. Let's get rid of some more space. Right, so doesn't copy through a spacing. Okay, let me talk you through what my code here is doing, and because it being jumbled together isn't helping. So I'll talk you through what's happening. So I'm bringing in a whole bunch of dependencies. So we're bringing in Express because we're going to create an Express.js server. I'm including the Apollo server tool because that's what we're going to use for actually doing all the mapping of schema to resolvers. And I'm also using a little tool here called import schema. If you remember, when I created the schema file, wrong thing. When I created the schema file, I created schema.graphql. That's not JavaScript. You need to compile GraphQL into a JavaScript object that Apollo can understand. So that's why I brought in a dependency called GraphQL import. What it lets you do is it lets you create .graphql files, and when and then when you want to, it will import. It will translate those into JavaScript. It just means that you can have .schema files, which just it makes them more interoperable and easier to manage, and the icon's nice. So, looking through the rest of the requirements, we've got the resolvers that we just talked about. So we have that object that's got a top level and it's got a query and everything like that. Type defs is so they're saying that my schema, which contains all my type definitions. So I'm using the schema tool then to compile those and bring them into an object ready to use. Then I create an Apollo server, and the Apollo server wants to know about your schema and then wants to know about your resolver objects. There's other properties too, but that's all we need for now. So it creates an instance of an Apollo server, and then I'm going to create my Express instance. I'm going to call it app for want of a better word. So I create an instance of Express. I call Apollo to say, right, attach yourself to this Express server. That's done. So that's the bit that does the magic. So now I've got an Express server that by default has a /GraphQL endpoint that I can reach. And then that passes all the calls through to the Apollo server. And then I've done a little bit of stuff here ready for React later on, where I'm saying, right, if you get any requests that don't match this, or when you get requests for the home page, it passes those through to the public folder that will eventually contain my compiled React.js application. Finally, pick up the server port from the environment in case you run on Heroku or anything else, and start the server up. That's it. So because you've heard I'm using Apollo, I have a schema, I have a couple of resolvers, I have a database, that should be the whole thing. So let's give it a go, shall we? So let's try the server out, shall we? So we start the server, and exciting that it says it's listed at port 4000. So let's see if it is, shall we? Start up a new tab. Localhost 4000, and as I said, it automatically exposes itself on port 4000 under /GraphQL, so it doesn't clash with anything else. And there we go, which has kind of spoilt it for me there, but let me talk you through that query about how I'm going to build it. So one of the things you get, so you've got /GraphQL, and one of the things you get for free with the Apollo server is something called a playground. That's why I went to this URL here. I went to Playground. If I just went to /GraphQL, it wouldn't be particularly interesting. But one of the things you get as a developer, and you can turn this off, is something called a Playground. Playgrounds let you experiment with the GraphQL server that you've got, so you can try out queries. And generally what you do is it gives you access to the schema, and it lets you build queries and try them out before you actually put them into your code. And the nice thing is, because we're going to use .graphql files, you can just cut and paste it in without any changes at all, hardly. So if you haven't done GraphQL, so we have queries, mutations. In this case, we're going to go for a query, and that schema file that we created, it's going to help us here. It's going to kind of give us some autocomplete. So we have a schema file here. That's from that text file that we created just now. So I want to get some to-dos, and I want an ID, and what else can I get from to-dos? According to this, I've got to-dos with titles and strings, so I want a title, and I want to know if it's complete. And then when I've finished doing that, bam, there we go. You have created your first GraphQL server. Wasn't that easy? That was even easier than Rails and all those other silly things. You always get back your stuff in a thing called data, and it returns back what you wanted. Now, you might not want to know whether something's complete for some crazy reason. So you just tell it you don't want that. That's the end of the first video in this series. You've set up a GraphQL server that talks to a Postgres database. You defined your schema, and you've shown how to use resolvers to pull the data out of that database. In the next part, I'm going to use ReactJS, ReactJS hooks, an auto-generator library, and I'm going to show you how you can then build a front end that uses the GraphQL API and together with TypeScript, give you auto-completion and type checking, and make it really simple to build forms and build screens to look at the data. See you then.